This is WebAssign assignment 10, question number 5. This problem is describing a bullet being shot into a baseball that's at rest, and then the baseball moves up, which kind of looks like this, and then the bullet will get stuck and then the baseball will move up. So since this is it's not an elastic collision problem, you need to do it a little differently. So if you take the momentum of the bullet and the baseball, and then set it equal to the combined momentum afterward, because it's not going to be created or destroyed. And then you write out the equation with what you're given, which is this. This is the mass of the bullet and its velocity, then the mass of the baseball, and then the velocity is 0 because it starts at rest, and then the combined mass because you have to, the mass is going to be combined after it gets lodged in the baseball, and then you're trying to find this velocity. So 0.032 times 238, and then that's just going to be 0, so you don't have to add anything, it's just 0. And then the other side, 0.15 plus 0.032, and then you're going to want to divide by that. So take this, divide by that, and so that's the velocity of around 41.8 meters per second. So you take that and then you bring it down here to these equations that we've already used, and so the velocity final is technically it's 0 in this equation, because once it reaches the highest point, when gravity is pushing down on it, its velocity is going to be 0. But the initial velocity is what we calculated for. So you plug that in, minus 2a, and you're trying to find that delta x, which is the distance that it traveled vertically. So velocity squared, and if you bring the, I just rewrote this equation using the numbers that we calculated. So that was velocity squared from before, minus 2 times the acceleration, which is 9.8 because gravity. And so you just switch this over here and divide by that, which is what I did. And the distance should be 89 meters, which is the answer.